Good morning, everyone. Myself Vidya Zuluk. My DMW mini project is about social distance detection. So first we will look at the algorithm used in the project, which is YOLO object detection algorithm. So first in this first slide, we will see how image classification is done. So firstly, we will detect if this is a dog or a person or any object is present or not. So if there is a dog, we will assign it as 1, and if it is a person, then it is 0. So and then object localization will be done by bounding a box around that particular object. So for particular object, for every object detected, we will have this vector of size 7 with the elements like PC, BX, BY, BW, BH in C1 and C2. For PC is for if there any object is detected or not, like if any, doesn't matter which object it is. And BX and BY are for the centroid coordinates, and BW and BH is height and width, and C1 is for class dog, and C2 is for person class. So in this picture we can detect the dog, so it is assigned as 1. In this next picture we can see there is a human object. So is there any object, so we will assign it as a 1, and accordingly the coordinates of the centroid and height and width of the bounding box. And for C1 class it is 0 because it's not dog, and C2 class it is 1 because we can see the human. In this next picture we can't see anything, so there is no object present in the particular frame. So in the first class like PC it would be 0, and the rest of the fields won't matter. So in Xtrain we have all the objects, or I will call it as a time frame for that particular video, in which we can detect object. And in y train we can have all the vectors uh, detecting all the information regarding the object. And this is how we will train our neural network, and we can uh, predict the particular vector for that particular frame. So in this is how we will like detect the object. So this works for only one object. What about the multiple objects in the image like this? So we will see for this case like this. In this picture we can detect two objects, which is dog and a human. So we will make grids. So these grids will be of any size like 4 by 4 or 10 by 10 or 3 by 3. So here we are taking like 4 by 4, and for each cell we will now produce a new vector of size 7. So for this first cell example, so is there any object detected? No. So PC class would be 0, and rest of them won't matter because there is no object in that particular frame. And for this, there is we can see the centroid for a dot object is detected in that particular cell. So is there any object? So yes, so we will assign 1. And for the coordinates for the centroid, we have taken the values, and for width and height of that cell, so we have taken those values, and it is a dog, so we have assigned 1 value, and 0 for the person. Next cell is for human. So is there any object? So 1. And these are like coordinates of the centroid. This is height and width, and we have assigned 1 for the person class. Next, if you can imagine this, whatever information we have, we are just showing in a particular way by this object. So if you can imagine, let's take these 4 by 4 is this are these grids, and particular vector is assigned for that particular cell. So this is just a representation in a 3D model we can see. So now again we have all those objects we have detected in X train, and Y train we have all the vectors, and then we can train our model now and make predictions. So what if there are multiple bounding boxes around a single object? So how we will know that, yeah, this is for that particular object? So neural network can detect multiple boxes around a single object. So we will see what we can do in particular case. So example, this is okay. So now we will take all the boxes which are detecting, and then we will find the intersection area. We call it as intersection over union. So this is the formula for IOU, intersect area upon union area. So intersect area would be like intersection of that particular boxes upon the total area, union area. So greater the IOU value, max would be the probability for the accurate box for that particular object. So in this picture we can see 0.9 is the highest value among these boxes detected over this person. So we will take 0.9 at this is as a final box for this particular object. Similar for this dog. So maximum IOU value is 0.81. So we will consider this as a final block. And this technique is known as non-max separation. Now, what we can do if we are detecting two objects in a single cell? So we will simply combine the vector of dog and person. So now we have vector for that particular cell of size 17. This is how we will train our object, and then we can make predictions. Now object tracking. So this is like, suppose this is object 1, this is object 2, and these are centroids, and id1 and id2 are simply their names assigned to them, and these are the bounding boxes. So how we will know that this object and this object is the same? Like if it's moving from this point to this point, so how we will know that this is the same person? So we will do what we will do, we will calculate distance from this particular point to the other remaining points. If we are calculating for this person, like if he or she has moved from this or from this point to anywhere else, so how we will know? We will calculate distance from this particular point to every point around it, and then we will use Euclidean distance to calculate this particular distance, and the minimum distance would be considered as the same object. So this is just assigned a name, and now we will see distance measurement. If this is a object and this is a camera, so we have simply this formula, f is equal to p into d by w. So p is a pixels and d is a distance upon width, with this width. So by simply manipulating, or we can say rearranging this formula, we can calculate distance. Okay, now we will see the code. In this first section, we can see model path is equal to YOLO Coco. This is actually, we have arranged all the objects that can be detected, and then initializing minimum probability to filter the weak detection along with the threshold when applying non-maximus separation. These are simply what we can say variable declaration. Now we will see the actual detection function. So I've imported necessary files and libraries, and in this section we will just simply grab the dimensions of the frame and initialize the to the results. Like this is the result list, we will just declare it. Now constructing a blob from input frame and then performing forward pass to the YOLO object detector. We will pass this information to our neural network. This is blob means this is a particular frame from the video. Then initializing lists, we will be needing this list afterwards. So for every frames in that video, we will detect scores, class IDs, and confidence. Confidence is nothing but how we are sure that it is a person or it is a dog for that particular classes. Then if class ID is equal to person ID, like whatever, uh, if it is a person, then we have assigned it as 1. So if that is true and confidence is maximum than this minimum confidence, then we can say surely that it is a person. So just um taking all all these values and creating the box. So for that box we are calculating x and y coordinates, and then appending the boxes uh, list and centered and confidences. Now applying non-maximum separation to suppress weak overlapping bounding boxes. Then ensuring that if detected uh, person is at least once, or otherwise we cannot uh, you know we cannot work further. So this is for that particular case, if the index is having at least one value, and then we can just append the result list. Now we will see the rest of the code. Here I have imported all the important files and library, and then loading Coco classes labels our YOLO model was trained on. So just initializing label path and labels, and then we will now load the object detector which is trained on the Coco dataset. This is initializing, and now we will just print. Now we have to print our output to the screen. Again, for every true value, we will read the frame one by one from that video, and writer is nothing but the it is a pointer, like it will track every frame from the video. If not grabbed, then we can break, and if it is grabbed, then we will work on it further, and then we will just set the violet value if length is greater than or equal to 2. Now we have to calculate the distance between the two objects. So this is necessary that value are 2 or more than 2, then we can calculate the distance between them by using Euclidean distance. For each value in uh, for each value that we have, we will calculate the distance, and then we will assign whether it is violating or not, and we will just update the violet list. Again, now this code is for to draw the bounding boxes around the detected object and plotting the centroid. Yeah, this is just like printing the social distance violation on the that particular frame. So we will be seeing the output on that frame for that particular time frame, so it keeps changing. So it this is just short, this code is for just shortcuts. Now we will see the output. First I will show you guys the actual video. So this is video 1, we can see. Now we will see the output for that particular video. I hope you can see this. So this value is keep changing because that output is for that particular frame from that video. I'll show you another. So this is video 2. Sorry. Okay, so this is the original video. Now we will see the output. So we can see the number of violations happening in the this particular frame. Okay, so that's it. That was my project. I hope you have enjoyed it. And all the images that I've used for this project are not mine. I've taken it from the Google. So I don't own any rights for all of the pictures that I've used. So yeah, thank you so much.